Hello learners, welcome to your favorite e-learning platform Pathshala. I'm Savita Chauhan, your mathematics mentor. Let's just start the chapter that we have started before, that is pair of linear equations. But before starting the definition or before going towards the main concept, that is the pair of linear equation, let's just talk about the linear equation in two variables. As we have already done with this concept, that what is the meaning of actually a linear equation in two variables. So let's just see an example of it. Let us suppose if we are talking about the equation 2x plus 3y is equal to 5, or if we are talking about x minus 2y minus 3 is equal to 0, or let us suppose if I am talking about x being equal to 2. All these three equations are actually called as the linear equation in two variable. But in the third example, as we can see over here, we have only x as 2. We can also convert this x is equal to 2 into the formation of x and y variable as x plus 0 into y is equal to 2. So it means that this equation can also be expressed into the formation of linear equation in two variables. So from these three examples, what we can say about the definition of a linear equation in two variable, that an equation which is of the form ax plus by plus c is equal to 0, where a, b, c are any real numbers and a and b not both 0, is called as a linear equation in two variables. So any equation which can actually be expressible into the formation of ax plus by plus c is equal to 0 is nothing but called as a linear equation in two variables, where always remember that a, b, c are any real numbers and a and b not both 0. So this is all about the linear equation in two variable. And moreover, we also have learned about the concept that is a solution of a linear equation in two variable. So let us suppose if we are talking about the solution of a linear equation in two variable, because this is really an important concept before going on to towards the pair of linear equation. So what is the meaning of a solution in the linear equation in two variable? So let us suppose if we are talking about any linear equation in two variable, that is 2x plus 3y is equal to 5. Obviously this is a linear equation in two variables because there is a variable x, there is a variable y. The highest degree of the variable is nothing but 1. So 2x plus 3y is equal to 5 is an equation as well. So this is nothing but a linear equation in two variable. So what is the meaning of a solution? Let us suppose if I am taking the coordinates of x and y as nothing but 1 and 1. Let us suppose if I am taking x as 1, y as 1. So let's just substitute x as 1, y as 1 in this particular equation. So if I'm substituting x as 1, y as 1 in this equation, I'm getting the answer from the left hand side. From the left hand side, as you can see, the left hand side of this equation is nothing but 2x plus 3y. The right hand side of this equation is nothing but 5. So if we are talking about the left hand side, and if I'll substitute x as 1 in it, y as 1 in it, then we will get the answer as nothing but 2 plus 3, which is equal to 5. It means LHS is equal to the RHS. So whenever for any value of x and y, the LHS of the equation would comes out to be equal to the RHS of the equation, then that particular value is nothing but called as the solution of that equation. So it means that x is equal to 1, y is equal to 1 is actually a solution for this particular linear equation. So I'm marking it as a right, or I'm saying that yes, it is nothing but the solution of this particular linear equation. So let us suppose if I'm taking another example, if I'm taking another coordinates as x as 1 and y as 7. So let us suppose if I'll substitute x as 1, y as 7 on the LHS of this equation again. So let's just substitute. We have 2x plus 3y. So if we are substituting x as 1, so it would be 2 into 1 is 2 plus 3 into y is nothing but 7. So 7 into 3 is nothing but 21. 21 plus of 2 is nothing but 23. So it means that the LHS that is coming out after substituting x is 1, y as 7 is nothing but 23. But as we can see over here, the RHS of the equation is actually nothing but 5. So it means that LHS is equal to the RHS. So whenever for any value of x and y, as we can see over here, for this particular value of x and y, LHS of the equation is actually not coming out to be equal to the RHS. As we have seen, LHS is coming out to be 23, but the RHS is nothing but 5. So 23 is not is equal to 5. It means that this coordinate or this particular point x is equal to 1, y is equal to 7 is actually not a solution. It is not a solution of this particular linear equation in two variable. So this is all about the solution of linear equation in two variable. So what we can conclude from this particular concept is that every solution of the equation is actually a point on the line representing it. As we have already done the chapter linear equation in two variables in the previous classes, so we do know about the concept that every point is actually lies on the line if it is a solution of that particular equation. Or what else we can say, that every solution of the equation is actually a point. It represents a point that is lying on the line that represents it. So for an instance, if I'm talking about the graph of a linear equation, so we always know that the graph of a linear equation is always a straight line, and on the straight line each and every point is actually representing the solution of that linear equation. So always remember that every solution of the equation is a point on the line that represents it. Moreover, what we can say further about the solution of a linear equation in two variable, further we can say an important concept that each solution which is of the type of the coordinate that is x comma y of a linear equation in two variable corresponds to a point on the line. As I'm already done with this particular thing, that it always corresponds to a point on the line representing the equation. Means if we are talking about the graph of a linear equation, so it always comes out to be a straight line, and each and every point on the line is actually representing x comma y coordinate type of a solution, and it is always called as the solution of that particular line or a root of that particular line. So always remember, each solution always corresponds to a point on the line representing the equation, which is ax plus by plus c is equal to 0. So this is all about the solution of a linear equation in two variable. Now why we are talking about the solution, or why we are talking about the linear equation in two variables? Because we do know that when two linear equation in two variables combine together, they form a pair of a linear equation, and that is actually our chapter today that we have to do. So let's just move on further towards the pair of linear equation in two variable, that what are or what is the general form of the pair of linear equation in two variables. So let us suppose if we are talking about the general form for a pair of linear equations, so it would be of the form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where always remember that a1, a2, b1, b2, c1, c2 are any real numbers with the condition that a1 square plus b1 square cannot be is equal to 0, a2 square plus b2 square cannot be is equal to 0. So this is nothing but actually representing the general form for the pair of the linear equation. So always remember, whenever we are talking about the pair of linear equation in the general form, then they can be represented as a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1, c2, all of these constants are actually representing the real numbers with the condition that a1 square plus b1 square cannot be is equal to 0. a2 square plus b2 square cannot be is equal to 0. So this is all about the general form for a pair of linear equation. Now let's just talk about the single line. Let's just talk about, if we are talking about just a single line over here, that is nothing but a1x plus b1y plus c1 is equal to 0. So if we'll represent this particular line on graph, then it definitely comes out to be a single straight line. Similarly, if I'm just talking about this particular equation, if I'm just talking about this particular linear equation in two variable, and if I'll plot this equation on the graph, then it would definitely again comes out to be a straight line. So it means that on the graph, if we'll plot both of these equations together, then they would come out as to be two straight line together. They would definitely comes out to be two straight line together. So let's just further talk about this particular concept.